All right, guys. Hey, go ahead and get that claim, evidence, and reasoning sheet from yesterday and just get it and have it there handy so you can refer back to it if you need to. Because we're going to do today something that's very similar to what we did yesterday and what we did on Monday. So you can use both sides of that sheet. And so if we go back to, actually it wasn't Monday, it was Tuesday. So if we go back to Tuesday, when we wrote the equation, when we used the geometry to come up with the equation of a circle, okay? And then yesterday, when we used the geometry to write an equation for a perpendicular bisector, okay? Today, we're going to do the same thing. We're going to use the geometry to come up with an equation, and then we're going to take the geometry to the algebra so we can come up with a working equation for a parabola. All right? So you guys remember back last year in algebra when you talked about parabolas? So how you feel about parabolas? I'm questionable at best with parabolas myself, so don't feel too terribly bad about that. Just remember from yesterday and from our diagram that we did way back in the first semester when we constructed that perpendicular bisector. Remember when we're talking about distance here, we're talking about a perpendicular distance, okay, between 2 points. Tuesday, it was the perpendicular distance from the center of that circle to the edge of that circle. Yesterday, it was the perpendicular bisector between 2 points. All right, so today, we're going to do that with a parabola. All right, so for the next 4 minutes, y'all answer these 3 questions. Answer them on the board behind you. Any questions there? We've done this. We've been doing this for a while. Yes, ma'am. Just like you did yesterday. Write them up there. You know, this is no different because I'm fighting with this board. There we go. All right. Casey. Wait, just answer these 3 questions. Yeah, we're not through that yet. Ooh. Ooh. So why are you changing yours? You don't want to be. You don't want me to ask you why yours was. What was the difference between yours and everybody else's? Yeah, you're getting a little ahead of the game here. But yeah, you're right. What does that mean? Huh? What does that mean? Don't panic. Don't panic. You're fine. I didn't say it was wrong. I just said, what does it mean? There, yeah, just put another one there. There we go. Now I know what it means. All right, so I'm looking, I guess everybody agrees that the answer to number 1, the distance from from 1, 3 to the x-axis is 3. Okay, so Logan, how's our come up with 3? So what'd you do though? How did you get the 3?
If you put it at 1/3 and go down to the x-axis, you gotta count down 3 to get back to it.
So you counted it. You just counted it, right? And you're able to count it because it was just straight down to it, right? Very good. Yes, ma'am. Yes, you may. You can. Yeah, you can write. Yeah, you can write on that packet that's in the basket. It's yours. All right. So everybody agrees then that the distance from 2, -5 is 5. It's not -5. So somebody explain to us how it's not -5. Dax, you already said it.
Yeah, you can't go negative toward the plane. You can't be a negative number away from something. Yeah. You can't move.
Because what is it?
Because you're still that distance away from the absolute value of it.
You're still that what? You said it.
The absolute value of it.
Yeah, but you said the word. It's the distance. Very good. Okay. And you're right, guys. You're right. All right. Don't want you to think you're wrong. The distance of a point away from another point is not. It's not going to be negative. Okay. It's going to be that many units, which I think is the reason that we all jumped up and put the absolute value sign around y. Okay. So what does that mean? Absolute value of y.
It's how far it is from 0.
Because the absolute value of a number is it's a distance. Okay, it's how far it is from 0, right? Okay. All right. Very good. Okay, guys. In the basket, grab a piece of patty paper. Everybody will need a piece of patty paper. Casey, you'll need a piece of patty paper as well. Here's some right here. Thank you, ma'am. Okay. On the patty paper, draw a point near the center and label it N. In the center of the paper. Just eyeball it in there. You don't have to measure anything. Just eyeball it in there somewhere around the center. And once you get point N on your patty paper, take the ruler and draw a line anywhere on the paper. Now make sure your line goes all the way across the paper and that it does not go through N. And once you get finished with that, then you guys can begin. So it does not go through N. Okay? And then y'all go ahead and start on 3 and 4. Yeah, make sure you draw it dark enough so you can see it. Okay? Yeah, and guys, it's actually easier to fold the line to the point than it is to fold the point to the line. And so start at the end of the line, fold the end of the line to the point, and then just keep folding the line to the point, but fold it in a different place every time. And just keep folding it and folding it and folding it. Casey, you doing okay? All right. Just like that. Fold it. Fold the line to the dot. Just like that. Is there more than 3 ways? Oh, keep folding it. Yeah, there's definitely more than 3 ways. Keep folding. Keep folding. Fold it. Move it up a little bit. Fold it. Move it up a little bit. Fold it. What's the matter? Or here, I'll get you a pencil. Just keep folding it. You'll see. Just keep folding it. Keep folding it. Here's a pencil.
Like anywhere like this.
How are you folding that? Show me how you're doing.
I do it like this.
Okay, so
My line was just
okay, so you did it like. I'll fold the line so it goes over there. Get you another one. Get another one. You still have plenty of time. Don't worry. Just get you another one. Keep folding. Keep folding and keep folding. The more you fold this, the more obvious it's going to get. Where's your?
I'm doing it right.
Where's your? Draw a line across there.
I did.
Where?
You can't hold this yet, but I did.
Just keep folding. Keep folding, and keep folding. All right, so now,
So my line has to be like right under it or above it. I made my line like this.
it's fine. Keep folding. You're doing, that's fine. That's perfectly fine. Keep folding. See how I'm doing that? Just keep folding it.
I don't know what the folding is. What am I supposed to do? What about this side?
No. You just keep folding this line. Just keep, all right, just come over here. Keep folding, okay? And move it again and move it up a little bit and fold it again. And just keep folding it, yeah. Move it up and,
I got the first one right.
okay.
I can do it like this.
No. All right, so we got it out here. All right, now fold it this way, okay? And then move it up and keep folding it, all right? And move it up and fold it again. And we're gonna fold it here for about another 90 seconds. Just keep folding. Oh, I see. Okay, so you've got to know. All right, so, well, maybe we won't fold it again. Y'all keep folding for another 80 seconds anyway. All right, so now look.
It's a bit of a parabola.
All right, so yeah. And the more you fold it, the more, okay, so what, now, everything, the edge of the paper that's not creased, now just take your pencil and trace over that.
Is there a parabola in there somewhere?
See the part of the paper that doesn't have any creases in it?
Oh, okay.
Oh, there we go. That's,
I'm seeing one too many triangles.
I'm not seeing.
look at the, lay it down flat. All right, look at the section of the patty paper that has no creases in it.
Oh, it's gigantic parabola. Well, how was it?
What? I mean, I hadn't folded it long.
No, you haven't folded enough. Keep folding.
Gigantic parabola.
Okay, see, keep,
I mean, you ain't really got that.
yeah, keep folding. Okay.
Yeah.
And keep folding and keep folding. It will appear. Now that's what number 4 says, y'all. Take your pencil now and trace around that edge where all of those creases come together. You see it? Show me. There you go. There you go. Very good. How are we doing over here, y'all? What's the matter?
I'm doing it right or wrong or doing it?
Yeah. You gotta take the line.
Oh.
Okay. There we go. Like that. Okay. And just keep. Okay. And keep folding. And keep folding. And keep folding. Okay.
Thank you.
You see it? Okay. Show it to me. Show me where's your parabola going to be. There you go. Just keep folding. You need a few more creases in there, Mason, so you can get it on there. Good.
So parabola is a U, right? What makes a V? What is that called? A V? Angle?
No, I know what it is.
Is this it?
That looks about like it. Yeah. Did you get it on there? Good, Trees? Very good. What's the matter? I've seen this. Look. Okay. All right. See where it's not creased? Okay. Draw that in there. All right. So we're at 2 minutes here. So is everybody? Did you get it? Keep folding. It'll keep folding. Yeah.
Like, I fold until there's no line back.
Huh? Yeah, keep now fold from this side. Ma'am? Yes, you may. You certainly may. Okay. Sharana, how we doing?
Good.
Are you still folding it this way? Are you folding the line you drew to the dot? Because all of these should be they should be coming together. See, look right. Mason, where's yours? See right here? See right here? See how it comes around right here? See? Okay. There, yeah, right. See? Okay? All right, trace that in there. Trace your parabolas in there, guys. And just keep, you're doing fine. Y'all are doing. Why? Why is it not?
What is this?
Well, you may have. Yeah, it's actually going to be up. See where the creases come through here? It's going to be right through here. See, right here? And
So
it's,
this
it's
is- it's
so
supposed to be right
this
here.
line right here is fine, and it's going to come down right through here. See it? See it right?
Oh, so now you're way
Yeah,
down
you
there.
came all the way down here. See, so you want to trace the edge that has no creases. All right?
No.
There you go. You see it? Do you see it in there?
No.
See right here?
Yes.
Okay. Follow it. Just follow it around. See it?
I don't even see the bend.
Oh man,
What?
I can see it with my old eyes.
Oh, my eyes say.
Look right here. Right here. See there? Whatever. Yes. Case. Yes. Yeah, this needs to go all the way across. Okay. Just hey, what you got? We're gonna show you here. All right. So y'all put those somewhere so you know where they are, because we're going to come back to them at the end of the lesson this afternoon. Okay, so this is kind of not as dramatic as we had hoped it was going to be, but so what shape emerges on the patty paper? A parabola, or as I've often been accused of saying, a parabola. Okay, yeah, that sounds like some kind of virus. So here's the geometric definition of a parabola. Guys, you have it on your handout, so you don't have to worry about copying that down. But the geometric definition is the set of points the same distance from a point and a line. Okay? So yesterday, we found the exact distance between what? Two different points. There you go. So we found the line. We found the bisector between 2 points yesterday. And then on Tuesday, we found that bisector between the center of a circle and the edge of a circle. All right, so guys, really, today is not much different than what we've been doing all week, but now we're going to be dealing with the set of points that are the exact same distance between one single point, that's the N on your paper, and the parabola. Okay? We've kind of already answered this question too. Why does folding give you the points that are the same distance from the point and the line? Because you're folding it onto the dot. So what is that? And that line represents the bisector. Good. All right. So from algebra, does anybody remember the formula? No. Or was it one of those things that you really tried hard to forget? Yeah. Okay. Well, here it is. All right, and it's on your paper. Here it is. All right, and now just like yesterday, when we talked about the standard form of the equation the standard form of a linear equation, right? Now you guys can think of another form of linear equation. Huh? Yeah, one of them involves, there are a couple different, which is a slope intercept, okay? So what we have here, guys, that's the standard form for a parabola. That's the vertex form. This formula right here, y equals x minus h squared plus k, will give us the vertex of the parabola. All right? Now, hey, on Tuesday, h and k represented what? But it was x and y, but h and k were the coordinates of what? What part of the circle? It's 1 point. The center. H and K represent the center of the circle. Okay? So here again, H and K are going to represent now the 1 point that's the vertex of the parabola. Okay? So we've seen this before. Don't panic. We've seen all that stuff before. All right, so here we go. Now we're going to derive the equation of the parabola using the geometric definition, just like we did on Tuesday with a circle, just like we did yesterday with a perpendicular bisector. All right, so make sure you keep your patty paper close because we're going to use it again at the end of the period. There's graph paper in the basket if you should need it. Okay, so here we go, 1 through 4, and then let's see if we can come up with that equation. And you could write them up here if you want to. Yeah, actually, no, let's go ahead and write them up there. Yeah, let's write them up there so we can talk about them. Yes, sir. I'm sorry. Does that make sense? Okay, all right. Yes, sir. Good job, baby. Y'all need some graph paper? We out right here? Is there not any in there? How many you need? You just need one? That's okay, you're fine.
It's a no. 4 is a no.
How you know? Convince me. Oh, see? Just leave it. Just leave it as square root of 10. Oh, no. 10 squared is 100. The square root of 10. Just don't worry about, listen, don't worry about that. Just leave it square root of 10. Remember what we talked about? That's actually a more precise answer. Okay? Yeah, unless you want to recite all those decimals. How we doing?
I don't remember how to set up the equation part, but I figured out the answer.
Okay, all right. So now, hey, look back at what we did. Oh, you weren't here. Look at that equation. Good, good. What's the matter?
I forgot the equation. How to write the equation.
That's look at this. Yeah, but you have it, or you have. Now that's the one we did on that's the one we did on Tuesday. That's the circle. Yeah, that's fine because look, I know what that is, and you know what that is.
I know what.
Okay, just make sure, right?
Make sure
Teach
what.
us how,
Well,
what it means.
tell them what that is.
It's technically the coordinates define the length
Yep.
between 2 points.
What's the name of that formula? What do you're trying to find a what with it?
Distance.
So what formula is it?
Distance for it.
Now you recognize it, right?
A distance
Okay.
form like-
See, we haven't mentioned that all week. So, see, now he's actually, Daryl's actually been using that all week, And we've been using the Pythagorean theorem. Sir?
The one that was on the board.
Yeah, where's your paper? Can we borrow this right here, Jess? Okay. So it's going to be a very similar equation to what we've been doing. Okay? That's why I want you guys to have that sheet from Tuesday and Wednesday.
It's gonna be this. And then are you gonna put the?
All right, now remember yesterday. Remember yesterday, right, where we said, okay, this part of the equation is this side, okay, and then we had the other coordinates on this side.
The coordinates of the x-axis.
So yeah, so look back at your you erased your warm up questions. Go back on your sheet and look at the warm up, okay, and see if you can come up with what that is equal to, because that part's good. That part's money.
Just be 2, 0. Since that's
Look back at the warm up questions. There. Okay, but what's this going to be? This is going to be equal to something. What's it going to be equal to? Because as it is, it's not an equation.
would you put the same number to the absolute value?
So we don't know. Okay, so you remember the answer to this?
Yeah.
What was the answer to that?
35.
What's the answer to this?
35, and it's absolute value of y.
Okay. All right,
It's the
but
absolute value of
okay,
x and then y.
yeah, okay, but no, it would be the absolute.
Oh!
It's still going to be
Equals the absolute value of y.
right.
That's all
Okay.
that
Now, but see how you got squared, so it's going to have to be what?
Wait, would you just write the same equation, put absolute value of y?
No, no. This is okay. It's just that's what it's going to be.
Just absolute value of y.
Very good.
What does it equals to?
Okay, let's look back. Let's look back right here. Okay. So what was the answer here?
3,
What was the answer here?
5, y.
No, it wasn't y.
Oh, I mean the absolute value of y. Wait,
Okay.
just put the absolute value of y?
Yeah, but now look, Logan. Okay, guys, look right here.
Oh, squared.
Okay, but now if you square it, do you have to say absolute value?
No.
No. Why?
Because when you square it, the
Oh,
value
because
won't
it's
be
gonna
the
be the
exact.
same.
Good. What's the matter? Huh? Okay. Can I borrow this? Okay. So the equation that you're coming up with is very similar to the equations that we've been coming up with all week. Okay. Well, hey, get him straight. What are you erasing?
Just rewriting.
Okay, all right. Okay, I started to say. Wow. Y'all kind of made short work of that. There you. No, it's perfect. It's perfect. No way. Where did the 6 come from?
Where are you playing at?
Oh, we're right there. My bad.
Where's the 6 coming from?
X minus 3 equals 1.
Yes. Yes, ma'am. Casey, you okay? You should. Yeah, okay. Perfect. It's perfect. Ma'am.
How do you actually like solve this?
That's what we're going to do. Okay. Now we've used the geometry, right? We'll let everybody get finished here. Hey. Okay, let's look right here. Look right here. Okay, remember this? Everything ties back together. Okay? So what was the distance here?
3.
What was the distance here?
5.
What was the distance here?
That's
Boom. So is there any difference between the absolute value of y? Okay, because look, if I square negative 5, what do I get?
25.
And if I square a positive 5, what do I get?
25.
Boom. You see? You see what I'm saying? So what goes here?
Y squared.
Boom. Got it. Very good. All right. Okay. Very good. Okay. Naturi, you want to ask the question that you just asked me so everybody can hear it, please. How do we solve it for, what are we solving it for? Guys, help her out. What are we solving it for? What does the equation say? Look back on your handout. What does the equation say? We want to go from that equation to vertex form. So what are we solving it for? We're going to solve for y. Now here's what we're going to do. Okay? Here's where we connect the geometry and the algebra. All right, so now we've used the geometry to come up with this equation. Okay? And we could use that equation to find the vertex of our parabola, but it would take some work. All right? It would be much, just like yesterday, where it was much easier to determine the points that were on that perpendicular bisector using the equation that we came up with. It's going to be much easier to determine the vertex of this parabola using the equation that we're going to come up with. So now we're going to put those algebra skills to work, and y'all's are better than mine. So help me out here. So here's where we're going. We're going to go y squared. Here again. No, I'm not doing that here. I'm not going to do that here because I don't want to have to erase and do all that. So here we go. Y squared equals that's it. All right. All right, so now, hey, we want to get this into vertex form. So y'all look back at that vertex form. Is there something that looks familiar in this equation and in that vertex form equation? No, the vertex form equation of a parabola that I showed you. It's on the second page of your third page of your handout.
I see.
What do you have there? What do you got?
Y equals to x minus h squared plus k squared plus with h.
Okay, right?
Yeah.
So look, this is already the way we want it. So we're not gonna mess with it. All right? It's already in the form we want it to be in, so we're not gonna mess with it. All right, so let's go. Y squared, we're not gonna touch this. All right, so remember from yesterday? Y'all remember this? Okay. So let's see, y minus 2, y squared minus 2y plus 4. Okay, so y squared minus 4y plus 4. Okay, so how many of you noticed the 2y squareds there and you kind of panicked a little bit? What happened to the y squared and the x squared yesterday? So we subtract those from both sides. Okay, so that leaves a 0 there. X minus 3 squared minus 4y plus 4. So what do you want to do next? Mason, what do you want to do next? Put what? Very good. How are we going to do that? Jess, how are we going to do that? There we go. So 4y is equal to x minus 3 squared plus 4. One more thing to do. Caitlin, what's the one last thing to do? Remy, help her. We already subtracted it. Well, I mean, if we subtract it, we're going to... So what does that mean?
Oh, divided by 4.
There we go. That means multiply, so that's fine. You saw 4. You're fine. You're good. Okay, so listen now. Remember, you got to divide everything over here by 4. Okay? So those are gone. I'm going to put this right here. So that's going to give you y. All right. Dividing by 4 means the same thing as multiplying by what? Very good. 1/4. So let's go 1/4 times, and 4 divided by 4. There's your equation. What's the vertex of that parabola? What are the coordinates of the vertex of that parabola, sir?
Do we need a calculator?
No, you can look at it. Okay, but is it going to be -3 or is it going to be +3? Right, because it's -3, right? Okay, so the coordinates of the vertex are what? 3, 3, 1. Good. All right, so now on your graph, plot point 3, 1. And tell us its relationship between the point you started with, 3, 2, and the x-axis. Where is it? It's halfway. It's halfway. The 3, 1, the vertex of your parabola is halfway between the point you started with, 3, 2, and the x-axis. It's halfway. Very good. All right, kiddos. Take your patty paper now, please. Okay, take your patty paper that you had that had the parabola on it. Okay, the line that you drew across there to start with, label that as the x-axis, please. The line that you drew on it is the x-axis. Okay, so now fold your patty paper to get the perpendicular bisector of that line. End to end, good. There, very good. Guess what that's going to be? Okay, so when you unfold it, go ahead and trace the crease with your pencil. And what's it going to be, Dax? It's going to be Y. Very good. All right. So we've got more than one copy at everybody's table. Okay? So y'all look at the different parabolas that you have at your table and give us, Mason, Marissa, Remington, Sharenda, one of you guys, give us one thing that you notice about the different parabolas. I'm going to put them on the spot here. Okay, we'll come back. Can y'all give us one, Dax, Addie? What's one thing you notice about the different parabolas? They are all the same shape. Well, yeah. That's kind of like those which one doesn't belong, and nobody ever wants to pick out the one that's the different color because that's too obvious. Okay, they are the same shape. You got one now, Mason? Y'all notice anything else? Caitlin, y'all notice anything else? Y'all talk about it. Done.
What about how wide it is?
Aha. So what about that, Naturi? Aha. Some are more narrow. Good. Got one now? Come on, Sharanda, what you got?
He said they are the same distance.
The same distance. Same distance from the center. Okay, we need one more. We got 4 groups. Matt, Jesse, Cameron, y'all give us one. Something you noticed. What about them? Okay, well, yeah, we need to get moving so we can get to. All right, we'll take that. Look, they're all a parabola, so they are all the same shape. Good. All right, some are more narrow than the others, so they're not all the same width. Okay, and they said the same distance from the center. Okay, same distance from the center of the parabola. Is that okay? Good. All right, so now let's do the same thing. So what's something that you wonder about those parabolas? Sir? Why are some more narrow? Very good. Good. Why are they the same distance? Okay, we've got 3 notices. Let's come up with one more wonder.
Why is it halfway to the x-axis?
Good. Very good. Why is it halfway to the x-axis? All right, very good. Okay. Now, guys, y'all keeping those, the notice and the wonder in mind. Here's the exit ticket today. Okay? So here we go. Keeping those things in mind that you just told me to write up there. All right? Oh, yes, you can. You have a blank one? Okay, very good. All right, so there's your note. All right, Case. Okay, here you go, Casey. There you go. All right, guys. We looked at a parabola formed by the x-axis using the point 3.2. What would happen to our parabola if we move the point from 3.2 to 5.4? Okay? How would the parabola change? Justify your reasoning. All right, so hey, what's the claim? How would the parabola change? Okay, so what is your claim? Okay, say it again. You're good with the. Okay, so now what would be your evidence? How are you gonna support that claim?
It has to be the same distance from the x-axis.
Aha. Okay. So what have we done in here that you could use as evidence to support that claim? Okay. All right. And then just like Tuesday and Wednesday, let's tie our reasoning is going then to tie our evidence to our claim. Okay?
The evidence would be the phone number, right?
That's take it with you. That's fine. You can take it with you, and we'll take them up tomorrow. Good job, guys. We appreciate it. Thank you. Great job. So, how you feel about those parabolas now? They're
Let's go through